All right, section 9.7, example 6. This is a good one. Yes, we are using law of cosines, but it's possible we can use law of sines later on. We're probably going to use the sum of the angles in a triangle theorem that they equal up to 280. So we're going to be using a lot of things. Now, I wrote the law of cosines here, and when I didn't even look at the book. So I have them memorized, and I didn't even really try to memorize okay, a squared equals b squared. There's the simple way that I just remembered it. So it's like the Pythagorean theorem, but when I start with a squared, I know I'm going to end with the capital A. And of course it's cosine because law of cosines. So I know it's a squared, it's going to equal b squared plus c squared minus 2bc, not the a. The a will not be anywhere in the middle, just the beginning and the end. B, beginning the end. C, beginning the end. And that's how I memorized it. I was pretty excited about that. Now, we need to solve this triangle and round our decimal answers to the nearest tenth. So we have to find lowercase c, uppercase a for angle A and angle B. I have side and an angle and a side, so it's like SAS. So that when you see that, you know you can use law of cosines. It's not a right triangle. It cannot use Pythagorean theorem. We cannot use sine or cosine. We have to use the law of cosines or law of sines. In this case, let's try to solve for little c, because we have capital C, we have lower a and lower b. We have all we need to put in here to solve for our lowercase c. And let's do that. Lowercase c equals lowercase b, which is, or a, lowercase a, so 20 squared plus 25 squared minus 2 times lowercase a times lowercase b cosine 40. Okay. 20 squared is 400. 25 squared is 625. I'm getting better at my squaring the numbers. Probably because they use these numbers frequently throughout other problems, so I've got some practice. Minus 2 times 20 is 40. 40 times 25 is 1,000. How did I do that so easily? Because I know 4 quarters is $1. So 4 times 25 is 100. If I have 40, you're just going to add a 0. 40 times 25 is going to be 1,000. Okay, so then c squared equals 1,025 minus 1,000 cosine 40. Now, I think if my memory serves me right, it's important to not go ahead and do the math here. You know, you might be tempted to go and type all of this in and then solve and then take the square root of that number. Don't do that. Just go ahead and take the square root of both sides and solve for c. So you're going to get the square root of 1,025 minus 1,000 cosine 40, close your parentheses. I get approximately 16.09, round to the nearest tenth, so about 16.1. All right, I'm going to write it on my diagram so I have it visually as well. Okay, now I'm going to erase all of this. I almost said delete. Erase all of that. I have all 3 sides. Now I need to find I have all 3 sides, which is SSS. So now I could continue to use law of cosines to find my angles, or I can use law of sines. So I'm going to try to do law of sines really quick. I don't have angle A, so let's solve for that one. Sine of big A over little a, which is 20. Sine of big C over little c. This marker is almost dead. Okay, To solve for sine A, we got to multiply both sides by 20. To get rid of that 20. So now we have sine A equals 20 sine 40 all over 16.1. Okay, let's put that in the calculator. 20 sine 40 and divide that by 16.1. I get 0.7985. 0.7985. I'm sorry, it's going at an angle because I'm writing sideways. Now I got to do the inverse sine to get that. So inverse sine of this number will give me my angle. So let's clear that. Inverse sine 0.7985 gives me 53.98. Round to the nearest tenth, you get 53.0. So 53. I'll just 53 degrees. All right. Now, I have two angles. I don't need to do law of cosines or law of sines. I could if I wanted to, but I'm going to save the time and the headache of doing those and just take these two, add them together, and they're 93. And all three triangles add up to 180. So let's find this one. Well, I got 93. Let's subtract. I have 87. 87 degrees. Okay, so now I've got all sides and all angles. If you want to see more practice with the law of cosines and law of sines, just send me a quick note and I'll be more than happy to do some extra questions for you.